Okay, nice simple circuit here. Helps to ignore like the meters, right? Okay, so we got a 3 ohm, a 5 ohm, and then we've got these two. We got to figure out what that is. They're in parallel, right? So that's going to be 1 over 14 plus 1 over 27. 1 plus 1 over 14 plus 1 over 27. There we go. That's what I'm trying to say. Okay, so 14 to the minus 1 plus 27 to the minus 1, the whole thing to the minus 1. And that is 9.2195 ohms. That's that guy. Then we have a 6. Then we have a 13 and 17. These guys are parallel, right? So that's going to be 1 over 13 plus 1 over 17, right? So in my calculator, I go parentheses 13 to the minus 1 plus 17 to the minus 1, end parentheses to the minus 1. And that is 7.366 ohms, okay? So now we've got a 3, a 5, a 9.2195, a 6, a 7.366666, and a 7. That's a series circuit, so we can now solve for A1. Let's do that. A1 is going to be V over R, and that's 23 volts divided by a whole bunch of things. Okay, so let's see. The first one is a 3. Then we go around here, there's a 5. And there's a 9.2195. Then there's a 6. Then there's a 7.36 bar. And then finally, there's a 7. Let's figure this out. All right. Let's clear this bad boy. 23 divided by, left parenthesis, 3 plus 5 plus. Now I got to find that 9.2195 guy. That guy. So I'm using my up arrow on my calculator. Just go up, 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 grab this guy, right? Plus 6 plus 7.3666. Let's find that guy. So now up arrow. There we go. Plus 7. End parenthesis. And this is 0.6119. 0.6119 amps. So that is this guy. Now A2 is exactly the same as A1, right? Because it's the same current. It goes through here, 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 here. A1 and A2 are the same. So 0.6119. Okay. V1 is going to be IR. And this is the current going through that resistor, right? So 0.6119. And then that resistance for V1 is 3 ohms, right? So times 3, that's 1.8358 roughly. So these are amperes, this is volts. Okay. Let's see, V1, V2 is also IR, just a different R, right? So that's 0.6119, and then the resistance is this 9.2195. So now I got to find that number. If I go up arrow, grab this whole number, times, now I'm going to go up arrow again and grab the other number, the 9. And that's 5.6 equals 5.64166. I'm going to say 7. 6417. Okay, we're V3. V3 is on the 6 ohm one. We can do that. That's not too bad. Equals IR equals 0.6119 times V3 has got a 6 ohm resistor in there. So let's grab that number. We're using that number a lot. Times 6. Okay, that is 3.67156. So 6716. 3.67156. 0.6716. Okay. Those are volts. Okay. And then V4 is also IR. Same current, 0.6119. And then this resistance is 7.36 bar. So what is that? Let's see if I can find that. There it is. So I went up arrow, grabbed that whole number. And now I'm going to go up arrow and find the 7.36 bar because I'm too lazy to type it in. All right, and that is 4.5078. So 50, I'll say 79. Okay, 4.5079. All right, so now we get to the meat of it, right? The current through the 14 ohm, well, this is our 14 ohm right there. Okay, well, that current for the 14 ohm is just going to be whatever this voltage was from here to here divided by 14, right? So it's going to be V2 divided by whatever that resistance is, which is 14, right? So that's going to be, because we're trying to figure out the current through just this guy, right? So V2 is 5.6417, and then we're trying to find the current through the 14 ohms, so we'll put the 14 there. If you're trying to find the current through the 27, you divide by 27. The current through this plus the current through that adds up to this. I'm just going to say, okay. So I'm going to find that 5.6417. Boom, divide by 14. And I get that it's 0.40297 amps. So 4030. All right. And then the current through the 17 ohm, it's right here. It's going to be whatever the reading is on this meter divided by 17, okay? So I17 ohms is V4 divided by 17, okay? Just V over R, right? And then V4 is 4.5079, and then divide that by 17. Let's find that. There it is. Divided by 17. And that is 0.265. It's 168, so 2652. 0.2652 amps. All right. Whoo. Yeah. All right.